Okay, so we're going to go ahead and start. The problems that you all see up here deals with density calculations, and I'm going to actually share with you how to solve this problem. All right, so if you are ready, let's get into it. It says a small stone causes the water level in a cylinder to increase from 33.0 milliliters to 36.2 milliliters. The stone's mass is 12.4 grams. What is its density? Now, here's what you've got to keep in mind. That with density, you're going to have two units, mass unit and volume unit, all right? In the event that you are given two volume readings, then that just simply means you need to subtract those two. So in this particular problem right here, where they give you two volume readings, I'm going to take that 36.2 milliliters and I'm going to subtract it from 33.0 milliliters, all right? Now, the reason is because this is a type of problem that deals with what's called volume by displacement, and that means that when you have an increase in your volume, then you have to subtract to get the difference of the two, all right? So when I subtract these two numbers, I get 3.2 milliliters. Now, I'm also given the mass, right, which is 12.4 grams. So in order to calculate my density, that's mass over volume, that means I'm going to put my mass, which is a 12.4 grams, on top, divided by 3.2 milliliters. All right, so let's see what we get when we actually divide those two numbers right there. I get 3.875, but we're going to round that off to 3.88 grams per milliliter. So my answer is letter A. Okay, letter A. All right. And at any point that you all are lost, make sure you let me know, okay? Make sure you all let me know. So this is problem number 4. All right, we're going to go ahead and move on now to problem number 5. All right. Now, again, as you guys read through these examples, make sure that you all see, like, what is given in the problem, and also know what is required of me in the problem, you know, in order to make sure that we get the problems correct. All right, so let me go ahead and get you guys on with number 5. Hold on one second, y'all. I'm just moving me out the way so I can go ahead and have most of the screen. There we go. Problem number 5. Now, in this particular example right here, they're telling you that a copper coin has a mass of, so that's your M, 8.92 grams. When dropped into the water, the level goes from 18.0 milliliters to 19.0 milliliters. So you're going to say 19.0 minus 18.0. That gives you 1.0 milliliters. This is a really easy problem, y'all. Density, of course, is equal to 8.92 grams divided by 1.0 milliliters. And yes, the answer is letter A. Good job, RJ. Letter A. See, that was straightforward, right? Pretty straightforward. So I'm going to actually skip to another type of example, all right, where you have to look at the data that you've collected to answer the question. So sometimes it'll have different parts to it, and you'll have to solve the problem based on the different parts that you have. So in this particular example right here, okay, let me go ahead and read this problem to you. All right. It says you're testing a jade figurine. The mass is equal to 45.0 grams, and it displaces water from 55.0 milliliters to 59.5 milliliters. True jade has a density around 3.0 grams per milliliter. Is it likely real? Now, in order to do a problem like this, you have to first figure out, all right, well, you got to calculate the density. Even though they told you what the density should be, you have to go through the calculations to see if that is, in fact, the way you should solve the problem. All right? So in this case right here, I have 45.0 grams, okay, as the mass. And then for my volume, remember, you're going to subtract those two numbers, okay? And when you subtract those two numbers, right there, you get 4.5 milliliters. Now, when you divide these two numbers right here, if your number does not match what the density of true jade is, then your answer is going to be no, all right? If it doesn't match. So in this case right here, when I say 45 divided by 4.5, I get 10. Well, if the density of my answer is 10 grams per milliliter, and jade has a density of 3.0, then the answer is no. This is not real. No, this is not real. Okay. So far, are there any questions about how I just solved this particular problem? All right. Now, here's a different type of example. Okay, thank you, RJ. All right. Now, here is another type of example where they're giving you some other pieces of information that you need in order to solve this problem. So now I'm going to put all the numbers on the same type of format. Hold on one second. And I'm going to actually see if you all can solve this problem. Okay, because it says in number 5, an alloy is made from 200 grams of metal A. The density of metal A is 8.9 grams per milliliter, and 150 grams of metal B, which has a density of 7.1 grams per milliliter. What is the approximate total volume of the alloy? So, what you have to do here, because I am a visual learner, I am going to actually draw this out so you all can see this, okay? And actually, since it's a piece of metal, I'm just going to draw a box, okay? A piece of metal. And this is density A, or metal A. 8.9 grams per milliliter. And they also told you that it had a mass of 200 grams, right? Well, in order to find the volume of this, the formula for volume is mass divided by density, which in this case is we're going to say 200 grams divided by 8.9 grams per milliliter. Now, you just cross out your grams because you don't need that anymore, okay? And you're going to get that first volume reading for that first metal. So 200 divided by 8.9 gives us 22.5 milliliters. That's the volume of metal A, okay? That's the volume of metal A. Now, metal B. Again, you're going to do the same thing. You're going to draw it out. And again, because I'm a visual person, I'm just going to draw it out over here so you all can see it, okay? The volume is equal to, so in this particular case, they told us that we have 150 grams, okay? Right there, metal B has a mass of 150 grams. And then the density of that particular metal is 7.1 grams per milliliter. Again, cross out your grams because you don't need those anymore. The units of grams are gone. And you're going to say 150 divided by 7.1. And you end up with 21.1. 21.1 milliliters. And again, that's the volume of metal B. Now, if you look at this particular problem right here, it asks you, what is the approximate total volume of the alloy. Remember, an alloy is a mixture of two or more different metals coming together. So all you're going to do is add the volume of A plus the volume of B, all right, to get your total. All right. So in this case right here, we know that the volume of A is 22.5 milliliters plus the volume of B was 21.1 milliliters. And when we add those together, what do we get? We get 43.6 milliliters. Okay, let me make sure I add those numbers correct. Okay, let's see. Hold on, y'all. Yep, 43.6. So, right here, the math ain't mathing in these answer choices. This is what happens when you're going fast. 43.6, right? 43.6 milliliters. So, letter B is the answer choice. It's the correct answer. Okay? Yes, RJ, yep, we're going to consider the sig-fig rule. And the sig-fig rule says, see, this is where we kind of get into some trouble. Okay? If your teachers tell you to keep the answer using the correct number of significant digits, technically speaking, 200 has one significant digit, 8.9 has two significant digits. So when you divide those two numbers out, you should technically have one significant digit. So, you know what I'm going to do on the next problem? I'm going to put a decimal at the end so that we don't get caught up in some of those stipulations, because based on my answers that I'm providing you all with, all the numbers are in three significant digits, because of the decimal that's present. But the principle of the matter still remains the same in terms of how to do the problems, okay? So let's do another example, all right? Let's do another one. And see, again, this also depends on what your professors or your teachers tell you guys to do. Some teachers are not as poignant on saying, hey, do the significant digits. Some teachers are, are going to stand on you with those sig figs. I'm going to roll back up to the top, and I'm going to get another example from the top that we did not get a chance to do. So if you were here with us last night, that's why you see some of the problems that were already written out. Okay, so I'm just going to scroll back up to the top. We're going to go to number 6 now. Okay, right up here, number 6. Because you all need to know how to use all of the operations of the density formula. So here's a little sidebar right here. If you ever forget how to find the formula for whatever you're working with, right? You draw this triangle out like the DMV, where we go get our licenses renewed, or the DMV area, DC, Maryland, Virginia, to help you remember this. If you cover up the D, then the formula becomes density is equal to mass over volume. However, if I cover up the V, then my formula becomes V equals mass over density. But if I cover up the M, guess what? We're going to multiply. And so my mass is going to be equal to density times volume, which brings me to number 6. And in number 6, it says you pour 200 milliliters of a bubble bath that has a density of 0.95 grams per milliliter. What is the mass? So all you have to do here in this case is say, all right, well, the density is 0.95 grams per milliliter, and you're going to multiply that times 200 milliliters. But you know what units get canceled out? Your milliliters, okay? And you're left with your grams. So 200 times 95 gives us 190 grams. So letter A is the correct answer for this particular problem. Letter A. If we take a look at the next example, okay? Number 7. Number 7. And let me scoot this one down so we can see it fully. Right here, it says a plastic sample has a density of 0.88 grams per milliliter and a mass of 22.0 grams. What is its volume? All right, so the formula is V equals mass over density. 22.0 grams divided by 0.88 grams per milliliter. Cancel out your grams, and you're left with the unit of milliliters, which is what you're looking for. So 22.0 divided by 0.88 gives us 25.0 milliliters. So letter C is our answer. All right? Letter C is our answer. And good morning, everybody. I hope you guys are doing well today on this snowy day. Where are you guys from? Where are you all coming in from? Since we have 11 students today, can you all put your state? I'll start. I'm in North Carolina. So where are you guys? Maryland. All right. Maryland. How much snow did you all get? Okay, Virginia. So see, I just said something about the DMV area. And to help us remember the density formula, and look at the first two students. We got Maryland and Virginia. Okay. California. I need some of y'all's weather over here. DC in the building. New York, Fola. Good morning. Georgia. I know y'all got hit down there too, light-skinned Lexi. All right. But you know what? Just because you all are not in school, well, let me say this. If school is in session and you did not go to class because, your professors, the school is closed, you still have to do your work, right? They are still not playing. We still have assignments to get done. Okay? Speaking of which, let's keep... Oh, y'all got 12 inches. Woo! That's a lot. That is a lot. Speaking of inches, let's do a quick conversion. Because these are things that you guys will see. For those of you all that want to take the TEAS exam, okay, you all may have to do some conversions. So let's see if we could do a quick conversions. 12 inches. Someone said RJ said they got 12 inches. Can we convert that to a foot? Y'all want to do a quick conversion? And y'all know this should be fairly simple, right? Just like that's right. It's equal to a foot. Yeah. Yeah, that's it right there. You know what too, y'all? Oftentimes when we're given problems like this and we have to do conversions, if you just remember certain key things, you all should do fine. Matter of fact, I have a little video that I did, it's a 30-second video with a formula guide that I actually put together for students so that when you're taking your test, you can just, get to it. Okay? Right. So for those of you all that are saying this, 12 inches to a foot, you just divide by 12. Because there are 12 inches in a foot. Yes, I can show it to you. Because you know that there are 12 inches in 1 foot. You just have to know the conversion factor. I could have made this a little bit more calculate. And matter of fact, I'm going to do something in a second with y'all. If 12 inches equals to 1 foot, then all you have to do is just take the 12 inches that we told you, put 1 foot on top, because that's what you're looking for, 12 inches on the bottom, and then cancel out your inches. 12 divided by 12 is 1. And that's why the answer is 1 foot. But suppose you all told me y'all got 30 inches of snow. Okay? 30 inches of snow. Let's do that. If you got 30 inches of snow, and I say, well, I need to know what that is in feet, you're going to say 30 inches, okay? And on the bottom, 12 inches is equal to 1 foot. Cancel out your inches, and then just divide those two numbers. Thank you, Fola. Appreciate you. You're going to say 30 divided by 12. So that's equal to 2.5 feet of snow. Okay? Let's look at our next problem. All right, so right here, it says water rises from 46.0 milliliters to 49.5 milliliters when a marble is added. If the marble's mass is 13.5 grams, what is its density? So again, here's the visual. For those of you all that are visual learners, here we go. You start off with 46.0 milliliters of water. But once you drop that little stone or that little marble in there, the water level is going to rise to 49.5. All you have to do is subtract those two numbers right there to give you your volume that was displaced. Then they told you what the mass was, right? They said it was 13.5 grams. Well, when you put those two together, density is equal to mass divided by volume. That's 13.5 grams divided by 3.5 milliliters. Okay? And then all you have to do is divide those two. And you get 3.857, which gets rounded off to 3.86. There you go right there, 3.86. Now, because I deal with a lot of nursing students, a lot of my problems are based on real life examples. So I'm going to give y'all some more examples that y'all can relate to from a real life perspective. In problem number 5 right here, it says a shattered glass jar was found at a burglary scene and had a mass of 4.652 grams. This is your first number. 4.652 grams. When the glass fragment was placed into a graduated cylinder, I'm a visual person, so I'm just going to draw it out. With 20.0 milliliters of water, the water level rose. So once you drop that piece of glass in there, the water level rose to 21.53 milliliters, right? So to get your volume here, you subtract those two numbers, those two volume numbers. You get V equals 1.53 milliliters. Well, you also were given in the problem the mass of 4.652 grams. So you have to get the density, which is equal to, again, mass over volume, okay? So we're going to plug the numbers in right here. The mass was 4.652 grams divided by 1.53 milliliters. All right? Okay, let's see. RJ, you're doing calculations on Newton's law of mass, but you're here because you'll be taking the T's. When are you taking the T's exam? And so, for those of you all that just calculated this, you should have gotten 3.04. Yep, good job. If you did that, good job. This is the correct answer. 3.04 grams per milliliter. Okay. Okay, so you got about 2 months. Are you prepared? All right, guys. Y'all ready to do the next one? Number 6. Number 6. Now, number 6 is one of my favorite problems. Hold on, I'm gonna tell you why. Well, because it trips students up. Okay? And I'm not laughing like that on purpose, but I'm laughing like that because I know some students tend to overthink the problem or they don't read between the lines. So I'm going to let you guys look at number 6 and let's see what you guys can do. Okay, you're preparing. Very good. Very good. In problem number 6, it says a train robber in a Western movie steals 3 gold ingots, each of which has a volume of 1,000 cubic centimeters. The density of gold is 19.3 grams per cubic centimeters. What is the mass of the 3 ingots? Now, I put that in bold print because I wanted you guys to actually read between the lines. For A6, you do have the correct formula to find the mass. Mass is equal to density times volume. But here's the question I want to know. They told you that the density of the gold ingot is 19.3 grams per cubic centimeters. But here's my question for you. What is the volume? What is the volume? So if we got 19.3 grams per cubic centimeters as the density, what volume are we going to use? Yep, we already have density. Yep. Ashton Lopez, you take a look at what you wrote. Where'd you get 51.81 for the mass? Okay, so let's take a look at this part. They told you in the problem you had 3 gold ingots. The key word here was 3, each of which has a volume of 1,000 cubic centimeters. Okay, each of which has a volume of 1,000 cubic centimeters. So therefore, because you have 3 of those, and they each have 1,000, they weigh 1,000 cubic centimeters as the volume, not weigh, but the volume is that. Your total volume for all 3 is 3,000 cubic centimeters. Okay, so now to get the mass is going to be equal to 19.3 grams per cubic centimeters times 3,000 cubic centimeters. Now, using the correct sig fig, so I'm going to put this disclaimer out here. Using the correct number of significant digits, I need to know what the correct answer is going to be. Because on the test, so many students get this one wrong because they put this as their answer and I mark it wrong. Because I told them to use the correct number of significant digits. In chemistry, the correct number of significant digits is based on the least amount of numbers that you have. So in this case right here, my answer should be rounded off to 1 significant digit because 3,000 only has 1 significant digit. Therefore, when I highlight this 5 right here to give me 1 significant digit, 57,900 gets rounded off to 60,000 grams as your final answer. And this is the chemistry way, guys. So for those of you all that are taking chemistry and you have to do sig figs, this is it right here. This is what I would be looking for. Okay. Any questions about that one before we move on to number 7? Why round? Are you still supposed to round up? Okay. Here, very good question. I love your questions. So let's talk about this for a moment. In chemistry, when we are multiplying and dividing, and if I put the disclaimer out that we're going to apply the significant digits rule, that means that 1,000 or even the 3,000, it only has one significant digit. So if we go back to our lesson on how many sig figs we have, 3,000 has only one significant digit, unless there was a decimal present. In this case, there was not. 19.3 has three significant digits. 19.3 has three significant digits. So when I multiply these two numbers out, I have to round my final answer based on the correct sig figs. Excuse me. So when I get 57,900, okay, the first significant digit that you see is the 5. The 7 tells the 5 to go up to a 6. So that becomes 60000. So that gives you your one significant digit in terms of your final answer, okay? That gives you your one significant digit in terms of your significant final answer. So a couple of weeks ago, I actually started this lesson on significant digits. So if you guys have questions about that, you can always check out my YouTube channel because I do have plenty of videos on that. But I also have them here on TikTok too, so you all can look at that as well, okay? If you all need further clarity about the significant digits rules. Well, if the moment you step into a chemistry class, very good question, RJ and Ash, Hannah Lopez, you all have very good questions. How do you know when to apply sig figs? The moment you enter a chemistry class, off the gate, always apply sig figs, unless your teacher says I don't care. But if you but here's the other thing too. If you guys are doing homework, like on mastering chemistry or Canvas or Canva or Blackboard or BrightSpark, whatever your platform is for doing homework assignments, the answers are going to always be based on the correct sig fig rules. Always. Always, always. So when we were doing these problems earlier, I really wasn't applying the rule because we were just trying to do the problems, right? But the rules were kind of implied with the final answer based on what you guys were getting. So when it comes to doing chemistry problems, significant digits are key, okay? They are very important to solving your problems. You're welcome. Let's take a look at number 7, okay? Number 7. So I'm going to go ahead and scroll up, and I'm sure some of y'all probably have already solved this one, okay, for number 7, okay? And it says, calculate the density of a 5.00 milliliter urine sample from a patient suffering from diabetes mellitus that has a mass of 5.025 grams. Okay, here's the rule for dividing. When you are dividing, you have to round your answer to the least of all the digits. So I've got 5.025 grams on top because that's your mass, 5.00 milliliters because that is your volume. On the top, I have 4 significant digits. On the bottom, I have 3 significant digits. But my final answer is going to get rounded off based on 3 significant digits. So when I plug this into the calculator, 5.025 divided by 5.00, I get 1.005, but I only need 3 of those digits. So here's what you're going to do. I'm going to block in the first 3 numbers, right? That 5 tells this 0 to go up. So your answer becomes 1.01 grams per milliliter. Hey, Kay, you said your issue is that you forget the formulas. Okay, let me tell you guys how to remember this, okay? Yes, I do. I'm going to review the formula for you. You're coming in at a good time. Okay, here is how you do the formula right here. And also, guys, I have a formula chart that you all can use that will help you remember certain things. Because I know, again, you can use your notes, yes. But more importantly, if you did not want to use your, thank you for your heart, me. If you did not want to use your notes and you want to use my formula guide, go look at my last video that I posted with me dancing and acting silly. But that's the formula guide that I have shared with students so that they can use that to help them remember for their test. Now, of course, I have to mail it to you, but you can just go to my website and actually get access to that. Okay, but it's a very helpful guide that you all can use for your test to help you remember key things like this. I actually have this on the guide too, where if you cover up the letter D, okay, and you're trying to remember, like I made the joke before, the DMV area, okay, or the DMV where we go get our licenses renewed. Density, by me covering that up, gives me the formula of M over V. On the other hand, if I cover up the V, then my formula is going to equal to mass over density. But if I cover up the M, then you all know that M is equal to density times volume. Okay? So that's how you're able to do the formula or remember the formula. Okay, you don't understand how to round up? Well, in order to round up, you got to go based on the rules, the significant digits rules. And the significant digits rules will tell you, okay? Oh, you're welcome. Matter of fact, this is a good segue, y'all. Hold tight. Let me go ahead and pull up my significant digits rules for y'all, okay? Because I think that that's going to help clarify some of these questions and concerns that you guys have. And I want to make sure that you're good before we move forward. So let me see if I can pull it up. Okay. Okay, so let me do this. I'm going to switch my screen, all right, so that you all can get access to it. Okay, you're welcome. Okay, so here it is right here. These are my notes that I give to my students, and these are the notes that you all can use as well. So I am zooming out so that you all can see it. There we go, right there. Okay, so when it comes to significant digits, rule number 1, all digits 1 through 9 are inclusive. That means they are significant. Take care, the math tutor. Number 2, zeros between significant digits are always significant. So that means if I give you a number like 3009, that has 4 significant digits. Okay, that has 4 significant digits. The 3, the 2 zeros that are sandwiched in between the 3 and the 9, therefore all 4 of those count. Rule number 3, trailing zeros in a number are significant only if the number contains a decimal point. So here's the example that I tend to give students to help them remember this, right? So if I wrote you a check, okay, as an example, for let's say $500, right? That number right there, the 500, without a decimal, that's only 1 significant digit. But the moment I write $500 and I put a decimal on the very end, I now have 3 significant digits. The decimal determines what's going to count, what's going to be a value, okay? That's what happens. Now, if you have a 0 in rule number 4 at the beginning of a number whose only function is to be a placeholder, then those trailing zeros are not significant. So as an example, if you look at the one that's highlighted right here, 0.00079, only the 7 and the 9 count. Only the 7 and the 9 count as far as being significant. And that's why you only have 2 significant digits right there. And then in rule 5, pretty much the same thing, but if the zeros come after a decimal and after a significant digit, then that's when those zeros count. So that means the 3, the 8 count, and then the 0 counts also at the very end. Same thing in this example right here. But if it was at the very beginning, like 0.000000380, only the 3, 8, and the 0 would count here in this particular case. I also mentioned the adding and subtraction rules, and that says that when you have the least amount of digits after the decimal place, that's how you know when to round your answer, okay? So you round your answer after the decimal place with the least amount of digits. So if I say 152 plus 3.41 plus 2.7, well, in this first digit right here, there aren't any decimal places. In this second digit, I have 2 numbers after the decimal. And in this last number, I have 1 significant digit after the decimal. But because 0 is the least of those digits, when I plug it into the calculator, I get 158.11, but my final answer should be 158, period. No decimals. And when it comes to multiplying and dividing, the rule says look at the entire number and round accordingly. So you're going to limit and round your answer based on the least amount of digits in your problem. So if I got those same 3 numbers, 152 times 3.41 times 2.7, well, guess what? The least of my digits are the 2. So when I plug it into the calculator, I get 1399.464, but I have to round it off to just 2 significant digits, and I get 1400 as my final answer. So if you need more clarity on this, by all means, take a look at it. My website, that too, but take a look at my YouTube channel where I have all these different examples up there, and also here on TikTok. So I have practice problems on density along with some exam type questions in my study guide. But then the other thing that I was talking about, it's a formula mat. It's front and back. You can actually get that where it has all the different types of formulas and tips and tricks to help you remember certain things on your test. I also have a mindset workbook that's free that you can also get, where it gives you some tips and tricks on how to be successful in your chemistry class so that you don't panic. Okay? And so if you click it, it'll take you straight there. You're welcome.